Welcome back to alcohol phenol chapter students, myself Mahesh. So yesterday last class we learned how to prepare a alcohol from hydroboration oxidation reaction and how to prepare alcohol from hydration of alkene and by using a reducing agent. So today's session let us study how to prepare a alcohol from Grignard reagent. So students, Grignard reagent means we know it is a one of the solvent or MgX. R is called as alkyl group and MgX is a salt. So in a first chapter we learned how to prepare a Grignard reagent. So the Grignard reagent formula is RMgX. When a alkyl halide reacts with a magnesium in the presence of the dry ether, we will get a RMgX. So the nature of RMgX, what is the nature of RMgX? Yes, here we have a type of, what type of bond? We have a covalent bond and we have a ionic bond. So both type of bond we can see in a Grignard reagent. As I said, how to prepare a Grignard reagent? When a alkyl halide reacts with a magnesium in the presence of dry ether, you will get as RMgX. So it is called as Grignard reagent. So just now we understood what is the nature of a Grignard reagent. So by using this Grignard reagent, how it is we can prepare a different types of alcohol. So here Grignard reagent is reacting with a carbonyl group. Carbonyl group means we know it is a aldehyde and ketone. It depends upon a number of hydrogen or number of alkyl group where on the either side of the carbon is attached. So I have taken a carbonyl group. So when a carbonyl group undergo resonance, when a organic solvent, when we introduce to a carbonyl group, so it undergoes a resonance to form a negative charge, to form a positive charge. So here the alkyl group which is rich in electron, it attacks where there is a deficiency in electrons in a carbonyl group. So where there is a deficiency in electrons, yes, here in a carbon the plus shows there is a deficiency in electrons. So the alkyl group will react near the carbon and remaining part the MgX part will react with the oxygen. So where the double bond breaks to form a single bond. So this is what the intermediate called adduct. Here you can observe the alkyl group is attached to the carbon and magnesium halide is attached near to the oxygen. So on the basis of the charge separation, so the Grignard reagent is reacted. Now this adduct, when it is hydrolyzed with water, immediately the bond breaks between the magnesium and halide. So the bond breaks between the oxygen and magnesium halide to form as a magnesium hydroxide halide. Because the water, when you split, we get as H and OH. So the magnesium halide combines with OH to form as a magnesium hydroxide halide. And the remaining part, the one of the H will react with oxygen to form as an alcohol. So here by using this Grignard reagent, by using the different the type of the carbonyl group, we can prepare a different type of alcohol group. Different type of alcohol group means 1 degree, 2 degree and 3 degree. So this is a mechanism. If you understand how these mechanisms will take place, definitely you can write the different type of alcohol that can be prepared by using the different type of aldehyde and ketone. And also the questions will be there, what product is obtained when you take a different type of carbon atoms which is attached to the aldehyde and ketone. And also they may ask this product, to get this product, what is the reactant that you will take to make react with a Grignard reagent. So students, we will go to the next slide by taking some examples how a Grignard reagent reacts with a carbonyl group. So here is the screen, you can observe there is a methanol. We call this is the simple aldehyde group formaldehyde methanol. Am I right? It is a methanol. HCHO is called as methanol. So I will write a open structure formula C double bond O. Here both side hydrogen and hydrogen is attached. Okay, so this aldehyde, this methanol, when it reacts with a Grignard reagent or MgX, so we know there is a charge separation. Here there is a partial negative charge, here there is a partial positive charge, here again there is a partial negative charge. So when this aldehyde, when this methanol undergoes a resonance structure because it is in a neutral, right? Before it is a neutral, when some reagent is introduced near the carbonyl group, it disturbs. Disturb means it is losing its neutral property. So then it forms as a dipolar in nature. One is negative, one is positive charge. Yes, we know it is a negative. This is called as positive charge. Now alkyl group will attach where there is a deficiency electrons near the carbon. You can observe this alkyl group is attached near the carbon. And remaining part, the magnesium halide will attach us near the oxygen to form as OMgX. Make note, we have taken only the formaldehyde. Other name of the methanol is also called as a formaldehyde. Yes, it is a formaldehyde. So now when this formaldehyde is also called as a methanol, when it reacts the Grignard reagent, this is we call as adduct, called as intermediate. When this intermediate hydrolyzes with water means we take as H and OH. OH will attach with a magnesium halide to form as a magnesium hydroxide halide, and H will combine with a O to form as a 1 degree alcohol. Make note, it is a 1 degree alcohol, students. So again, now I am taking the second, means other than methanol, the same aldehyde group only I am taking, but other than aldehyde I am taking, other than the formaldehyde I am taking. Other than the formaldehyde means you can take the ethanol, propanol, butanol, any aldehyde other than formaldehyde. Okay, so other than formaldehyde when you take, when it reacts with a Grignard reagent, so here you can observe there are two alkyl group which is attached to the carbonyl carbon. One is from carbonyl, one is from Grignard reagent. So which is called as adduct, intermediate. So when it is hydrolyzed with water, so magnesium halide to form as a magnesium hydroxide halide, and hydrogen will react with oxygen to form as a 2 degree alcohol. So now you understood, when you take a formaldehyde only you will get a primary alcohol. When you take other than the formaldehyde you will get a 2 degree alcohol. It's a very simple. So that's what the previous slide what I explained, how a mechanisms will take place. If you understand, then you can give any type of products. Now let us take other than, means aldehyde we have taken like formaldehyde, and one more is other than the formaldehyde. So now here if I take the ketone, so the ketone also the same reactions will take place when it reacts the Grignard reagent or MgX. So the same mechanisms will take place to form a adduct. When it is hydrolyzed with water, we will get as magnesium hydroxide halide, and it is called as 3 degree alcohol. So students, by using a Grignard reagent, now we understood we can prepare all type of alcohol, 1 degree, 2 degree, 3 degree. So you should note that when 1 degree alcohol is obtained, when 2 degree alcohol is obtained, and 3 degree alcohol. So 3 degree alcohol, no doubt only the ketone part. If the ketone part means both carbon side, if alkyl group is attached, CH3, as here CH3 is attached, hence it is said to be as what we call ketone. Ketone is also called as acetone. Am I right? So this is about how to prepare a alcohol by using a Grignard reagent. Okay students, now till now we learnt a sp3 hybridized OH where it is attached to the carbon, that is what we call as alcohol. So many methods we learnt how to prepare a alcohol. Now let us come to a preparations of phenol. Phenol means is also called as a carbolic acid where OH group is attached to sp2 hybridized benzene structure. Aromatic structure is also called as hydroxybenzene, is also called as phenol, is also called as a carbolic acid. So we have 4 method of preparation of phenol. The first method, let me take from alloharine. Alloharine means we have chlorobenzene, bromobenzene, that also you learnt in a previous chapter how to prepare a chlorobenzene, bromobenzene by using a Sandmeyer's reaction. So in a what actually organic chemistry, if you select any one chapter, that will not work, because there will be a link. Even if suppose if you select only the second chapter, that second chapter will be a link with first and third chapter. So you cannot neglect any one chapter. So you have to take the first chapter, you have to study what is Sandmeyer reactions. So it is a method of preparation of the chlorobenzene, bromobenzene. So now here, okay, we have prepared a chlorobenzene. Now only the concept is how to prepare a phenol from different method. Which method here? Alloarine method. So when this chlorobenzene reacts with a sodium hydroxide in the presence of 623 Kelvin. Why we are giving so much temperature means a alloarine is less reactivity. Alloarine is a very less reactivity towards a nucleophilic substitution reaction. So only here we are increasing the temperature 623 Kelvin. Okay, it is 623 Kelvin, the atmosphere pressure is 300 atmosphere pressure. So what happens, that sodium and, so that the H and Cl will combine to form as a HCl. So minus I will write as HCl, and ONA will attach with this carbon group to form the sodium phenoxide. Again I will repeat, H will combine with Cl to form as HCl, and sodium oxide will react over on the benzene structure to form as a sodium phenoxide. So for this sodium phenoxide, when you add a few drop of acid, hydrolyzed with water or acidified water, if you add, immediately what happens, we will get as a phenol. So the mechanism, so the Na and Cl will combine to form as a salt. So this is how we prepared a phenol by using a alloarine. So okay, let us go to the next step. So this is the second method of preparation of phenol by using a benzene structure. So benzene means the C6H6 when it is reacted with the oleum formula is H2H2O7. When a oleum reacted with a benzene, and or if it means without using oleum also we can prepare by using a hot conc H2SO4. Because what is the difference between these two means, we are prepared sulfuric acid by using a oleum. Here if you are not using oleum means then no issue, you can use the hot conc H2SO4. So this oleum or hot conc H2SO4 when it reacts with a benzene, we will get as a benzene sulfonic acid. Further when it reacts with the sodium hydroxide followed by acidified with acid, so we will get as phenol. So this step is also very simple. From a benzene by using a oleum we will get as an intermediate called as benzene sulfonic acid. Again when you add a sodium hydroxide followed by acidified water or acid, you will get as a phenol. Now the third method, very important method of preparation of phenol from diazonium salt. As the previous slide I explained, chlorobenzene is prepared from a Sandmeyer reaction. Sandmeyer reaction means the preparation of the chlorobenzene, bromobenzene. How we prepared chlorobenzene? When you take a aniline, aniline means a amino benzene reacts with a nitrous acid, HNO2 with a few drops of conc HCl. When you maintain the temperature 0 to 5 degrees Celsius or 273 to 278 Kelvin in the terms of Kelvin or in the terms of the degree Celsius, you will get a salt called as a benzene diazonium salt. So that benzene diazonium salt, now there is a small layer, just we are deviating the reaction, because when you warm with water, just you warm with water, you will get as a phenol plus nitrogen gas plus HCl. So here we have a amino benzene. Amino benzene is also called as the aniline. Am I right? It is aniline. Aniline when it reacts with a nitrous acid. See here, the nitrous acid is obtained from the sodium nitrate plus HCl. The formula of the nitrous acid HNO2. When this nitrous acid reacts with the aniline, we will get as a salt called as a diazonium salt, benzene diazonium salt. Yes, it is a benzene diazonium salt. So here we are using the HCl when we got as a benzene diazonium chloride. When you warm with water, we will get as phenol. So it is a very important. So possibilities more to ask how to prepare phenol from a chlorobenzene or from a aniline. So they may ask in any way, but the product is obtained phenol when you change the deviation, means when you add a water, when you warm water, when you add, immediately we will get as a phenol. So we will go to the next method of preparation of phenol. Yes, important, very important students. From a Cumini processes, Cumini is a processes of preparation of a two products. One is a phenol and one more is acetone group. So, in this Cumini, we have taken a isopropyl benzene. The Cumini is also called as isopropyl benzene. It is isopropyl benzene, other name of this Cumini, because we have a 3 carbon atom. It is in a isomerism state. Okay. So, when this isomerism oxidized, so you can observe between the C and H there are two oxygen, means we call as a hydroperoxide. The Cumini hydroperoxide is obtained when a Cumini or isopropyl benzene, when it is oxidized, we get a Cumini hydroperoxide. Further diluted with acid, few drops of acid, students, or else you can write as H plus also. Here H plus also you can write. So when you add a few drops of an acid, what happens? We will get as a phenol, and another byproduct, what I said, it's called as a ketonic group. Ketone is also called as acetone. So here the question how they will ask during the Cumini processes, what is a byproduct? So it is a acetone, and this method usually we use in an industrial method, this preparation of phenol as well as the ketone, because we know ketone or the acetone is one of the byproduct where we use to remove a like nail polish remover, and also to clean a whiteboard, that marker pen, when we use, if the mark is not removed, then we use a acetone group. It is a very volatile in nature. So these are the, because of that property is very important, that's why we use this method in the industrial to prepare a phenol plus acetone group. So I hope you understood. This is a reaction out of the 4 method of preparation. The one is from chlorobenzene, the second one is how to prepare a phenol from a benzene, the third one is from alloharenes, means by using the aniline diazonium salt we got, further warm with water you will get as phenol, and the last step is Cumini processes. So very important, out of the 4 the Cumini processes usually they will ask. Okay students, now we will see the preparation of phenol by using the Grignard reagent, because we use to prepare a alcohol by using a Grignard reagent. Am I right? So here also we are preparing a phenol from a Grignard reagent called as RMGX. In the place of R we are taken as a phenyl, that's it. Only in the place of R we are taken as a phenyl. Magnesium bromide, when it is oxidized in the presence of a dry ether, we will get as a phenoxy magnesium bromide. Again here also when it is acidified with water, you will get as a phenol. This is also a very simple method. Try to remember how to get a phenol from a Grignard reagent. Means Grignard reagent means in the place of the alkyl we are using as a aryl group. Aryl means the benzene group. The phenyl magnesium bromide oxidizer to give as a phenoxy. This is a phenoxy magnesium bromide. Acidified water, you will get a phenol group. Okay students, till now we learned the preparation of alcohols, the preparation of phenol. Very simple. If you first initially you remember orally how a product is obtained, what type of reactants if we take. So that will be a first step to understand the reaction, how it will. If without knowing the product, without knowing the reactants, if you practice, there is no use. So here after studying the properties, after studying the preparation of alcohol and phenol, yes, obviously we will go to the physical properties. So only I have taken alcohol and phenol. Initially I said only we are taking the alcohol and phenol. Here physical properties of alcohol and phenol. Usually alcohol and phenol is having a higher boiling point. If any organic compounds, if it is having a higher boiling point, you should remember, yes, there is a formation of hydrogen bond. Then here alcohol phenol is forming a hydrogen bond. So if it is a forming a hydrogen bond, means then that organic solvent should dissolve in a water. Because of solubility only, because of the formation of hydrogen bond only, because that is what boiling point is increased, or boiling point, it has a boiling point. So here now we understood alcohol and phenol is having a boiling point. But when you compare with the previous one means we have a alloalkane, alloharine, We have a hydrocarbon in the 11th grade chapter. Am I right? So when you compare all these hydrocarbon, alkynes and now we are studying the ether. Apart from the alcohol and phenol, we are studying about the ether also, right? So compared with those three, alcohol, phenol is having higher boiling point than the hydrocarbon, then the ether, then a haloalkane. So I hope you are understanding. So then you should understand, if it is having a higher boiling point means then there is a formation of more hydrogen bond compared to these all the examples. So now it is very clear, it has a solubility in water, it has a formation of hydrogen bond, because of that reason we have a more boiling point. And also I compared with some examples, hydrocarbons, etc. Okay, now I will speak specifically only alcohol and phenol. When you take alcohol, when a number of carbon atom increases, means the alkyl group increases, what happens? There is an increase in molecular mass. When there is an increase in molecular mass means the formation of hydrogen bond is more, or there is an increase in van der Waals force. See, you can write in any way why alcohol is having a more boiling point than the ether or than the hydrocarbon. You can say yes, because of the formation of hydrogen bond or because of the more van der Waals force. So number of carbon chain increases within alcohol, the boiling point also will be increases. Now okay, just you imagine we have a more carbon atoms. So in stride and OH group is attached, functional group. This carbon chain, when I fold, just I am decreasing the chain. Decreasing chain means just I am increasing the surface area of that carbon group. So when you increase the surface area of the carbon group, there is an increase in the boiling point. Suppose when you decrease the chain, what happens? There is a decrease in boiling point. Why there is a decrease in boiling point? Because in the decrease in the van der Waals force, that's what we call as isomerism. Suppose if you take the 5 carbon atoms, 1, 2, 3, 4, 5, and here OH group is attached. This is what the alcohol. So we have the 5 carbon atoms, 1, 2, 3, 4, okay, 5. So now this we can write even 1, 2, 3, 4, 5 OH, right? This is also one of the structure, right? Is isomerism of alcohol. Then we can say this is a isomerism and surface area decreased and decrease in the van der Waals force. Compared to this, it has a lesser boiling point. So I hope you understood between how a boiling point increases. So when we understand how a boiling point has increases, the same time the boiling point decreases when a number of carbon atom decreases because of the decrease in the van der Waals force. Let us see here, the hydroxyl group chiefly determines the physical properties of the alcohol and phenol. Not only alcohol and phenol, students, in any functional group. So the physical properties will vary because of the variations in the what we call the alkyl group. So the CH3 group or the benzene group. The nature of alkyl and aryl group modify this property to some extent. The boiling point increases with increase in the length of the carbon chain. This is due to the increasingly strong London forces as the van der Waals forces as the length of the carbon chain increases. So you can observe here there is 1 carbon atom, 2 carbon atom, 3 carbon atom. So when the number of carbon atom increases, the boiling point also will be increases. So and also here boiling point is increasing, or suppose if you take the ether and alcohol, when you compare, the alcohol is having more boiling point, means you should understand that alcohol will dissolve easily in water compared to the ether. Okay, here you can observe I have taken a butanol. So the butanol means the C4H10O. So the boiling point of alcohol decreases with branching because of the decrease in the van der Waals force or because of the decrease in the London force. So now here you can observe I have taken the 4 carbon atoms where the boiling point is 117 degrees Celsius, and at the same time the 4 carbon atom, when I change it to the branch means isomerism. So here also you can observe 1, 2, 3, 4, am I right? So then here is the boiling point compared to this one has decreased. Still I increase the chain, then what branch its point, then what happens? There is a decrease in the boiling point. You can observe there is a difference. So the molecules attains a spherical shape. Yeah, it attains a spherical shape with a branchings and the surface area decreases. As a result, the van der Waals force of attraction becomes weaker, so that boiling point decreases with a branching. So very important in all the chapters, functional groups, physical properties, the acidic nature, these are all very important because they will ask by comparing with the some other examples. So you can see there is a branching is there, so lesser boiling point than this. Okay, we'll go to the next slide. So yeah, students, as I already said, alcohols is having a higher boiling point than the haloalkanes, than the ether and even the hydrocarbon of comparable molecular masses. What do you mean by the comparable molecular masses? Here the alcohol is a functional group of ether. Ether and alcohol both are functional groups, right? C2H5OH is the alcohol, CH3O, CH3 is the ether. So both are same number of carbon atoms, same number of oxygen atoms, hence it has a comparable molecular masses. Is they have shown what is the boiling point. You can observe initially I have taken the alcohol molecular mass is 46. So the 46 is the what is that, ethanol, and again the same thing ether. Just I said both also having the same number of carbon atoms, same number of oxygen, hence the molecular mass is same. But here you can observe the boiling point is more than ether. Why? Because of the formation of hydrogen bond. What type of hydrogen bond? Intermolecular hydrogen bond. So alcohol, you can observe here, this is a alcohol group, this is also another molecule of alcohol. So between these two alcohol there is a formation of hydrogen bonding. What type of hydrogen? Intermolecular hydrogen bonding. So again I am taking the hydrocarbon. You can see the hydrocarbon, we have the 6 carbon atoms, but it is a comparable molecular mass. It is not exactly same, it is a comparable. So here also you can see there is a lesser boiling point. So then you can observe when you compare with the ether and hydrocarbon, ether is having slightly boiling point more than the hydrocarbon. Then yes, here also there is a formation of hydrogen bond, not much stronger than there is alcohol. That's why the boiling point is slightly more than the hydrocarbon. Hydrocarbon, there is no chance. So there is no formation of hydrogen bonding. There is no compare with the ether and alcohol is a very less. Means hydrogen bonding is there. Means to break that carbon and hydrogen needs energy. So but how much energy is required? 231 Kelvin. That much of temperature is required. So the next one is alloalkanes. So again, if you take the alloalkanes, there is a comparable molecular masses. We have a very less boiling point. So now you try to remember in the order: first alcohol, the second one is ether, the third one is hydrocarbon, the last one is alloalkanes. Now again I am taking the phenol group. So the phenol group is sp2 hybridization. The phenol, see the comparable molecular masses, the phenol one, the second one is the fluorobenzene. So the fluorobenzene and phenol both also having the comparable molecular mass, but the phenol is very more boiling point than a fluorobenzene because of the formation of intermolecular hydrogen bonding. You can observe this is one alcohol, this is one the phenol. So boiling point, no need to remember the values, but you should understand the concept by comparing with other hydrocarbon or alloalkanes, etc. Yes, already I explained the solubility. Yes, the alcohols shows a solubility with the water because of the formation of the hydrogen bond. If it is forming a hydrogen bond, means of course we should understand yes, it is a dissolving in a water. So alcohols and phenols both are soluble in water because of their formation of hydrogen bonding. The second point, solubility decreases when the size of that hydrocarbon, the alcohol or whatever the phenol, so increases, what happens? The solubility will decreases. For example, when you take a xenol, when you take a propanol, we have a 3 carbon atom, xenol we have a 6 carbon atom where a OH group is attached. So when a number of carbon atom increases, the solubility will decrease. So here we call as hydrophobic. Phobic means is a phobia, means it will not dissolve, it will not react with the water. It's a phobia. hydrophobia means it will not react, repulsion will take place. So hydrophobic alkyl or aryl group, whatever, because we are taking both alcohol as well and phenol. The next one is the solubility of the substrate phenols is less than phenols. What is the meaning of that? When you take this alcohol, we can see there is a formation of hydrogen bond. When you take the phenols, the solubility of the substrate phenols is less than the phenols. Means the phenols, there is no substrate groups, right? Only one aryl group we have. Suppose when you increase the aryl group in the phenol, so then what happens? Of course, the solubility, even if it increase aryl group also, the solubility will decreases. So I hope you understood the boiling point and solubility of alcohol and phenol, and what is the reason? Because of the formation of hydrogen bond, because of the presence of the intermolecular, that is also very important, intermolecular hydrogen bond between the two molecules of different, two molecules, alcohol, it is an interstate between the different states. The same way between the different molecule, there is a formation of hydrogen bonding, that's why we call as intermolecular. Intro means within a molecule, so that we will study later. Yes students, now after studying the preparations of alcohol and phenol, after studying about the physical properties of alcohol and phenol, now let us come to the chemical properties of alcohols. Alcohol shows a versatile in nature. Versatile means which acts as a both electrophilic in nature as well as a nucleophile in nature. Here electrophile, alcohol acts as a both as a electrophile and as well as a nucleophile, means which acts as a both Lewis acid as well as a Lewis base, rich in electron, deficiency in electrons. That's what we call as electrophile as well as a nucleophile. So when it acts as a electrophile, when it acts as a nucleophile, so there is that differs with the cleavage of the bond between the alcohol, the chemical properties of alcohol. It is a versatile in nature where it acts as a electrophile as well as a nucleophile, means the Lewis acid and Lewis base, it depends upon the cleavage of oxygen and hydrogen and cleavage between the carbon and oxygen. Now in detail, let us study how a alcohol acts as a electrophile in nature and nucleophile in nature, means the cleavage between the carbon and oxygen and the cleavage between the oxygen and hydrogen. Yes students, here as already I said in a previous slide, the alcohol acts as a versatile in nature, means which reacts as either a nucleophile or a electrophile in nature, Lewis base and Lewis acid in nature. So when an alcohol reacts as a nucleophile, so that time the bond between the oxygen and hydrogen is broken. So you can observe here the bond between the oxygen and hydrogen broken to form as a or acts as a nucleophile in nature. At the same time, when a alcohol acts as a electrophilic in nature, the bond between the carbon and oxygen, the bond between the carbon and oxygen, and here the bond between the carbon, oxygen and hydrogen. So that time it acts as nucleophile and it acts as electrophilic in nature. Here you can observe when a bond, so you can observe that ROC, that carbon cation, when it reacts with this very rich in electrons, so it forms as a, it acts as a nucleophilic in nature. And at the same time that bromine anion, which acts means it reacts with the one of the carbon after losing that oxygen and hydrogen from the alcohol, so that time it acts as a electrophilic in nature. So very important, again on this basis the question will be there, we will see the reaction, how it acts as a both electrophilic and nucleophilic in nature. So it is very clear. Suppose if you are confusion with how a alcohol or when a alcohol acts as a electrophilic in nature and nucleophilic in nature, means that answer or that confusions will given by these examples. Now we will see the cleavage between the oxygen and hydrogen. So when it takes a cleavage between oxygen and hydrogen, so we can say that alcohol acting as a acidity in nature. Acidic in nature means, yes, what we call the alcohol when it is reacted with a highly reactive metal such as a sodium, aluminium, these are a highly reactive. So this reactive metal when it reacts with the alcohol, there is a liberation of hydrogen gas. This reaction shows that is acidic in nature, means alcohol is liberating a hydrogen, that's why it is acidic in nature. And even you can take another example, when you take the aluminium. Yes, when the aluminium reacts with a tertiary alcohol, you will get as a tertiary butyl aluminium oxide. So plus hydrogen gas is liberated. This reaction is also showing that there is a liberation of hydrogen, means that alcohol showing a acidic in nature because of the cleavage between oxygen and hydrogen. Not only this one, even if you take the phenol, the cleavage taking place between the oxygen and hydrogen, when it reacts the sodium to liberate hydrogen gas to form a sodium phenoxide. So here when this phenol reacts with a sodium hydroxide, we will get as a sodium phenoxide and water, but the same time when you take alcohol, when it reacts with sodium hydroxide, there is no byproduct, there is no product, because there is a lack of acidity. But at the same time when you take the sodium, when it reacts with alcohol, you will get as sodium alkoxide. But when you take the sodium hydroxide, there is no reaction due to the lack of acidity. Now as I said, alcohol acts as a versatile in nature, it acts as a Lewis acid, it acts as a Lewis base. So that example I have taken, the alcohols and phenols or a Bronsted acid. Means what is the mean by the Bronsted acid? It donates a proton to a stronger base. The base means which accepts hydrogen. So donating hydrogen means it has a strong acidic in nature. So that we call as a Bronsted acid. So when you take the base, so the base means which accepts hydrogen from the alcohol. So alcohol as well as the phenol we are taken. The OH means the alcohol or phenol. So that alcohol or phenol, when it donates a hydrogen to the base, then it becomes a conjugate acid and conjugate base. This reaction shows that alcohol as well as the phenol acts as a Bronsted acid. So very important. Again we will continue this one by taking the acidity of alcohol. Yes, the acidity of alcohol decreases in the order. For example, number of carbon atom increases to the OH. So what happens? The carbon or the alkyl group has a nature to donate electrons, hence the electron density will be increases on the oxygen atom. That is a one point. Initially we know alcohol is acidic in nature. Why it is acidic in nature? Because there is a polarity between the oxygen and hydrogen. There is a polar in nature between the oxygen and hydrogen. This polarity increases. When the polarity increases, then the ease of hydrogen decreases. So when the polarity increases, when the number of alkyl group increases, then the electron density also will be increases on the oxygen atom. Am I right, students? Try to understand, near the oxygen, when a number of electrons increases, there is a increase in the electron density on the oxygen. Then the polarity disturbed. When the polarity disturbed, then the acidic nature also disturbed, right? If you see here, there is a tertiary alcohol. So this tertiary alcohol, we have a 3 alkyl group. There is a 3 alkyl group. So 3 alkyl group also gives electrons to the carbon. Carbon means that oxygen, the electron density will be increases between the carbon and oxygen, hence the polarity will decreases. So polarity, when it increases, the ease of the hydrogen will reduces. So again if you take, in this case only one alkyl group is there. So in this case the polarity is very less between the oxygen and hydrogen. So if the polarity is very less between the oxygen and hydrogen, then what happens? There is a increase in acidic nature. So in this way the acidity will decrease when you increase the number of alkyl groups. So 1 degree, 2 degree, 3 degree, only on the basis of the acidity level. So you can come to this is because of the fact the acidity decreases with the increase in the number of electron releasing alkyl group. So that time the plus side, the inductive effect or the resonance effect increases the electron density on the oxygen, therefore decreasing the polarity of the OH bond. So if there is a decrease in the polarity of the OH bond, so the acidity of alcohol also decreases. So hope you understood the acidic nature of alcohol, phenols. Yes students, let us come to this acidic character of alcohols and phenols. So as we learned in the previous slide, alcohols and phenols both shows acidic in nature. So what is the here alcohols shows acidic in nature because of the polar in nature, the O and H. The O and H, the OH group shows a polar in nature. Because of the polar nature only, that alcohol shows acidic in nature. Fine. So now when a number of alkyl group increases, what is the nature of the alkyl group? It is a plus psi effect. So means it donates the electrons or it increases the electron density on the oxygen. When the electron density increases on the oxygen, then the polarity of the OH bond decreases, hence the polarity decreases, even the acidic nature also decreases. It is a very simple. When a number of alkyl group increases, it is a plus psi effect, then it increases the electron density, hence the polarity decreases between the O and H, hence the acidic strength will decreases. So here you can see that I have taken the number of alcohols like 1 degree, 2 degree and 3 degree. So the 3 degree alcohol is a very less acidic strength because there are 3 alkyl group where there is a liberation or release of electrons more on the oxygen, hence there is a decrease in the polarity and hence the acidic strength also decreases. Again when you come to the 2 degree, the 2 alkyl group, so it has a plus psi effect. There also acidic strength will reduces by these 2 alkyl group, but in this case there is only one alkyl group, hence the release of electron is not much, hence the acidic nature we can see in a primary alcohol compared to the secondary and tertiary. So here what is the fact behind this that shows acidic in nature means that acidity decreases with the increase in the number of electron releasing alkyl group, plus psi effect of minus R resonance increases the electron density on oxygen, therefore decreases the polarity of OH bond. When there is a decrease in the polarity of the OH bond, then we can say there is a decreases in acidic nature. Very important question, students. This is what the acidic nature of alcohol. Even we will study about the phenol also. So in this slide we can see that comparing the acidic nature of alcohol, comparing acidic nature of alcohol with water. Generally everyone they know is alcohol is more acidic in nature, but when you study the chemistry, then we come to know that alcohol is a very weaker acid than the water. How sir? How can we say that alcohol is a very weak acid than the water? Yes, let us see here. So here I have shown the acidity nature of alcohol is less or water is more than the alcohol. Now here to understand the concept of how a water is a more acidic in nature. So here I have taken a water plus alkoxide ion. What is the meaning of alkoxide ion? Yes, it is a O minus, RO minus and water H2O. So here I have taken H2 as an acid and alkoxide ion, RO minus is a base. Here the water, from the water one of the hydrogen is giving to the alkoxide ion. If hydrogen is giving means then it should be it is a stronger acid because this alkoxide ion is accepting a hydrogen. Am I right? It is accepting a hydrogen, then it is called as a base, then we call as a conjugate acid and conjugate base. So this reaction shows that water, one of the hydrogen is giving to the alkoxide, hence the alkoxide acts as a weaker acid than the water. And again here alcohols can also act as a bronze state base. What is the meaning of the bronze state base? That is what the proton acceptor, right? You can see here that alcohol when it reacts with the HCl, HCl is a stronger acid than the alcohol, because when you take comparing with the water is a stronger acid than the alcohol. Make note, because the coming class we will study about the phenols, how the acidic nature will get vary. So here only we have taken the alcohol and water. So alcohol and water, when you take the water is giving hydrogen, the same time when you react with some mineral acid HCl, that hydrogen will give to alcohol to form as a hydronium ion, or we call as a alkoxide ion and chlorine anion. So this is how acts as a bronze state base which accepts a proton. Okay students, in the next class we will continue with so it is the acidic nature of phenols. We will study in the next class. Thank you.